All right, good evening and welcome. Thanks for joining us for the second or the concluding part of the foundation of security in AI. Last week, we started this conversation, and Toluwani, thank you so much for being present and sharing some basic foundations of what we need to understand about security in AI. I think particularly you looked at the AI security challenge, and then the governance and the regulatory frameworks. And then I think we concluded with AI's risk assessment and the foundation of AI risk assessment. And you mentioned some quite interesting thing around the exposures of AI and the risk that are inherent in adoption of AI, and why we also need to make sure that we think a lot around the data that we use for AI. I think one of the contribution we had was that sometimes AI need to be in context, particularly for Nigeria. Most of the AI systems are not local, and therefore the context in which those AIs were designed, they are kind of not very familiar with our context. And I think we agree that we need to make sure that we contribute to AI through even providing data, because once the data is inclusive, most likely we will have an AI that will be inclusive without bias to anybody's consideration. So today we want to complete that second part, which is securing AI systems in practice. And I think you can have the mic, and then let's see how we go today. Thank you.
Okay, Wally, please confirm if you can see my screen.
Yes, I can.
Okay, yeah, thank you very much. It's evening at my side. Good evening, everybody, and welcome to this call. And for those who joined last week, thanks for joining again, and I hope you gained 18 or 2 from the session last week. And for those who are joining for the first time, welcome to this session, and I hope, again, you get to learn 1 or 2 things that will improve your job in practice. Because again, I think the focus of this call is to provide bits from practical experience that can help us secure artificial intelligence in our workplaces and deliver significant value. And also want to appreciate the Cybersecurity Monitoring Group for inviting me for the second time to facilitate. Yeah, so this is just the brief agenda for today. We'll have a brief recap from what we did last week. And today, basically, we'll be looking at data security and privacy in AI. We'll be looking at secure AI development and deployment. We'll be looking at how to build AI security strategy. And we'll have some time to wrap up, ask questions, and contributions before we finally call it a day. Yeah, so for last week, that was the session 1, and we had a lot of conversations around AI security landscape. And there we looked at definition of artificial intelligence. We look at the practicalities of AI, of artificial intelligence in business operations. Also, we looked at unique attack surfaces such as adversarial attack, data poisoning, prompt injection, model theft, supply chain risk, and also model inversion. Then we had some time to discuss about governance framework. We took a deep dive at surface level, a deep dive into ISO 42001, that is the Artificial Intelligence Management Systems. We looked at the EU AI Act. We looked at the NIST AI Risk Management Framework. And also we discussed about the UK AI Principle. And also in closing last week, we discussed about how to conduct risk assessment for artificial intelligence systems. And from last week, just a recap, we look at artificial intelligence. Basically, what is the definition for artificial intelligence? So for me, artificial intelligence are tools that try to mimic human understanding or human capacity. And of course, AI has come to stay. AI is no longer a new thing. AI is part of business operations. And for any organization that is ignoring the use of AI as we speak, is just like an ostrich burying his head in the sand. There's a lot of shadow AI going on in different organizations where staff and business operators have are beginning to use AI and the organization is not aware. It's not that they are not aware, but they are not providing governance for AI. And are beginning to have a lot of shadow AI, and that comes with a lot of risks, such as privacy risk and confidentiality risk. A lot of risk coming up with that. So for any organization that is worth their onions, and for any progressive organization, AI governance, AI security is something that should be looked at. And so that should be looked at. And also we looked at the kind of attack. So AI has brought the use of AI in organizations have brought about new risk, have brought new attack surface into cybersecurity, into information security governance. And we had conversations around that last week. I'm sure Wale will share the video of our conversations last week. So without wasting more time, today we'll start our conversations with data security and privacy in AI. Why is data important in AI? Data is the bedrock of AI because AI is a learning system. It learns. AI is non-deterministic. So again, alluding to what we discussed last week, for traditional software that we have, the Microsoft Words, the other kind of applications we have, they are deterministic. And deterministic means that when you put an input into those applications, it processes it. And after processing it, we have defined set of outputs that we expect. So for every input, you expect a certain range of output. But for AI, because AI is a learning system, learns through data, same input might give different output depending on how the input relates with the data that the AI tool has learned from. And again, AI is non-deterministic. So the bedrock of artificial intelligence is data. And because the bedrock is data, we need to now provide a lot of security and assurance around the data. And of course, using data again exposes us to other risks, such as privacy. And today we'll start to look at the privacy considerations for AI systems. Of course, AI tools start with, or AI development starts with training data. You have to get a set of data, train them on expectations, and this data is now used to provide further outputs. And apart from training, there are some privacy concerns because this data belongs to individuals, or they belong to organizations, or they belong to nations. And of course, there are some privacy requirements around this data. So we'll look at training data security, we'll look at data privacy techniques, we'll look at bias as a security concern. And bias, again, as we discussed last week, bias is when AI starts giving output that is not totally representative, data that is skewed against a demography or a set of the society. And also we'll look at we just look briefly at some regulatory compliance, UK GDPR and NDPR as we go along. So we'll begin with securing training data. We're going to look at data integrity, provenance, and lineage. Now, what is data integrity? Data integrity is the ability of the data ability of data to be able to maintain its pristine state, both in storage and in processing. And we're going to look at controls that we can implement to ensure that data integrity is maintained, such as version controls, automated anomaly detection, and input validation. Also, we're going to look at data provenance. And what data provenance basically is just looking at the origin and the lineage of data. So when we say the origin, where are you getting the training data from? How are you processing the training data? And how are you storing the training data? We're going to look at how we track origin of data and its ownership, how we document collection method, because that is very important. Where are you getting the data from? How we maintain the chain of custody of data, and also third-party data audits. Then for data lineage, we get this data, we begin to transform them, we begin to train them. So what kind of transformation are we conducting on this data? How do we record pre-processing steps? How do we track the changes that happen to this data? And can we reproduce these changes? Can we are we doing adequate logging? Are we able to reproduce the steps, especially for explainability and accountability? Are we able to reproduce the steps that that makes our training data, or that makes our AI system produce outputs? Yeah, so why is data our number one asset when it comes to AI? Because number one, data shapes behavior. So unlike traditional software, like we said earlier, for traditional software, code determines behavior. And that is easy to audit. That makes it easier to audit traditional software, because all you need to do is just to provide governance around your code. But AI models learn their behavior entirely from data. So that means if you have compromised data, or if you have poisons data, then the error that is in the poison data propagates into the outputs we get from AI systems. Then, of course, data is very, very hard to audit. For source codes, for application codes, it's easy to audit. You have that. You can provide restrictions with access controls and other controls, and it can be easily audited. But data is very difficult to audit, in the sense that for very large AI systems, most of the data we use is not even from the organization that has developed the large language models, the AI models. Therefore, this data, so good AI systems, or very, very useful AI systems, they come with millions of records. And in these records, there can be hidden biases, there can be subtle poisoning and mislabeled examples. So I give an example here. Hidden biases. So, for example, we're trying to train a data in Nigeria. We're trying to train an AI in Nigeria that is meant for recruitment, and we're using recruitment data from the UK, or recruitment data from America. Therefore, there'll be some biases, because the recruitment process and the employment process in those jurisdictions are different from what we have in Nigeria. Also, subtle poisoning or mislabeled example. So, for example, if for self-driving cars, we've seen examples, or we've seen situations where the AI system or the AI model is trained on traffic signs, and then there are people who have tried. So these traffic signs: stop, wait, go, and the AI systems recognizes the pattern, or recognizes these instructions. But then you find, so for the stop sign, if there is a little perturbation, if there's a little change in the sign, then the AI system is not able to interpret it to be what is supposed to be. And of course, we understand the tragedy that can happen if a self-driving car is supposed to recognize a sign and stop, and it doesn't. It will continue moving, and that can be catastrophic. So hidden biases such as subtle poisoning, mislabeled examples, maybe statically invisible. So we need automated tools. Manual review is not sufficient for data audit. Then also, data has a supply chain. Like we said, most AI systems don't generate their own data. For large language models, what you find is data scraping from the internet. Some organizations even buy data from third party. And for this third-party data that is bought, they rely on third-party data annotation, that is labeling of third-party data. So again, if there is a risk, if there is mislabeled data from the supply chain, if there is biased data from the supply chain, effectively that will affect the outcome or the output that will be generated by the AI system. Also, data persists in the model. And what this means is that data's influence in AI is very, very important. So you cannot simply delete data from a training model. So the data is embedded into the AI model, and the AI model interprets scenarios, interprets outcome based on the data that is fed. So now I think we can appreciate why data is important and why is our number one asset in artificial intelligence. Now, we get data from different sources, but there are restrictions and constraints around this data. So we've got, and a major consideration about this data is privacy, because this data is either owned by people, natural persons, is either owned by organizations, or is owned by nations. And then there are some privacy concerns. The UK GDPR, the EU GDPR, the NDPR in Nigeria, some American states have got their data protection law, some Asian countries have got their data protection. So again, acquiring data for training to train artificial intelligence model has a lot of constraints, but there are some controls that we can implement to minimize the risk from the data. The first is differential privacy. The second is federated learning. The third is data anonymization. And the fourth is homophobic encryption. And we'll look at this one after the other. Yeah, so discussing differential privacy. So differential privacy is the main idea about differential privacy is that we is to implement controls around the data to introduce noise. And when we say noise, to introduce added data into existing data to ensure that no single individual data can be distinguished from the result, to ensure that the result of the training, we cannot say this data came from this person, this data came from this country, or this data came from this organization. So it's subtly introducing or noise or excess or additional data into the training model. And we need to appreciate that privacy is a big concern globally, and in every country or every region that has implemented privacy, there is cost to privacy breach, either financial cost, reputational cost to organizations and to sector. So how do we implement differential privacy? So is to add noise or extra data. We call them perturbations to the training data. And while doing this, we need to be careful that the noise or the extra data that we are adding does not ultimately dilute the meaning of the data, because we are getting this data for training for specific purposes. And if the noise we add to it makes the data unuseful or gives an extra meaning to the data, then the data is no more useful for our use. But the point is that we want to ensure that privacy breaches do not occur from the data that we are using to train our artificial intelligence. So there's always a trade-off. More privacy means more noise. For more privacy, that means you need to add more perturbations into the data. But for the more perturbations you have, then you begin to get less model accuracy. So organizations must decide the level of accuracy loss that is acceptable. But the main idea here is that differential privacy is to ensure that you've gotten data that you've gotten data for your training that can identify natural persons, but you don't want that. Definitely, you need to add some noise, some perturbation, some extra data to ensure that the single individual's data cannot be distinguished from the result. However, the more perturbations you add, the more the less accuracy you get from those models. So organizations must decide on the amount of noise they want to add to this data in line with the objectives of the artificial intelligence systems or the language model that they're trying to train. That's differential privacy. Then for federated learning. So for federated learning, the idea about federated learning is that you don't want to train all your data. You don't want to silo all your data. You don't want to store all your data in one repository. So what you want to do is that you want to distribute the model and train them differently. So you get, it's like creating different silos within the information processing facility of the organization and train those data individually, so that if you have silos 1 to 3, silo 1 does not have information about the data in silo 2. Silo 2 does not have information about the data in silo 3. So again, if you train them that way, what we are doing is that we're trying to minimize transversing of data into different locations. So what we are doing here is that we're training the data locally, and each participant trains the model with their own local data, and the raw data never leaves that location. Only what is done is that when those data are trained in different silos, the model updates, the learning from those data is now imputed into a central processing system or a central server where it is aggregated. But of course, this doesn't come without challenges, because in practice, we find that model update can still leak information. Gradient attack inversion can still occur. But what we can do here is that see on updates can still help to mitigate this risk. But federated learning is not a complete privacy solution. So all these controls that we are discussing in this session is not absolute. They are layers of protection. Differential privacy is not enough. Federated learning is not enough. But then organizations must be able to understand the risk of the data they are handling in training their AI models, and how they can build these controls as layers of security to provide privacy governance for training data. So we've discussed about differential privacy. We've also discussed about federated learning. Now we're looking at AI bias as a security concern. Of course, bias is one of the major risks of AI, and a lot of organizations have lost financially and they've lost reputationally because of bias. And what is bias? Bias is just AI systems providing outputs that is not totally representative of the population. And bias models, they produce unreliable outputs, and this is a very, very large constraint on integrity. And attackers, one of the goals of attackers is to deliberately introduce bias through data poisoning. And of course, bias in AI systems can cause regulatory, legal, and financial, as well as reputational damage. And we've seen in practice biased decision in hiring, lending, law enforcement, which cause direct harm to a segment of the people within the economy or within the society. And how can we prevent bias? Because it's a serious concern. Number one, we need to ensure that the data that we are using for training is diverse and is representative. the training data is biased. Is representative. So a very good example, if you are developing an AI model for lending, for credit in Africa or in Nigeria, for example, let me use Nigeria as a use case. You are developing an AI system for lending in Nigeria. Definitely, you need to understand the lending practice in Nigeria. You need to understand the financial system in Nigeria, and you also need to get data of lending data within the country. Because if you use uh, training data from South Africa, use training data from Zimbabwe, use training data from Europe, that might not be representative of the financial environment within Nigeria. So we need to ensure that for training data, we get diverse and representative training data sets. And also, there are some bias detection tools, such as Fairlearn, AI Fairness 360, that we can run our training data through, and it's able to highlight some bias within the training data. Then also there should be regular fairness audits across protected characteristics. So for this regular fairness audit, so for example, you have developed AI models that is assisting with um, human resources systems. So you are using AI systems to sift through recruitment data, CVs, and recruitment process. So regularly, it is required that we conduct fairness audits to be able to see how is this AI system processing recruitment data, and what output is it providing. Because as we go along, we are able to we'll go through some real life examples of bias that has been introduced in some AI system and what it costs those organizations. So we need to do fairness audit, and this fairness audit is to see how well the AI system is processing the data it is getting, or is processing customer information in line with the goals for which it was set up. Then very importantly in AI system is human in the loop. Some people call it ETL, or some human in the loop. And human in the loop is very, very important for high-stake decision, especially law enforcement and medical systems. So we've got AI systems um, that are making decision on imaging. So, for example, we've got AI systems that help with cancer detection and other tumor detection. We've got AI systems that help law enforcement make decisions. These are high risk decisions. So the practice is to ensure that after the AI system has made its detection, human beings make the final call. Human beings review what the AI has detected to ensure that it is correct. Although this is not to say that AI is not useful, because in practice we've been able to see AI systems is it has been found out that AI systems have discovered cancer and other tumors from imaging faster than human beings or medical doctors can detect them. However, the practice is that after AI has made its decision for critical systems, human beings should review to see the adequacy or the correctness of the decision that is made by AM. Then, of course, continuous monitoring for bias. Because when you set up an AI system, you feed it with data. It learns from the data. Users begin to use these AI systems and they're beginning to make decisions based on the output of the AI system. As time goes by, there's something we call drift. And drift happens when the data you input into the AI system, or the data through which the AI system is making decisions, is not representative of recent realities in practice. So a good example, you develop a system for recruitment that has been working for a while, but now the government has introduced some regulations in recruitment within the country, but you don't feed the AI system with data that contains the new regulation that has been introduced by the government, definitely there will be a drift from the decision. So the decisions the AI system will be making for recruitment will not be realistic because it doesn't contain the most recent data. So to reduce drift, we must ensure that there's continuous monitoring of the output of AI, and we also ensure that the AI is being fed up to date data to be able to make reasonable decisions. Now, AI real world failures, AI bias. Let's look at AI bias. So in 2018, Amazon developed an AI system for recruitment, but the data the AI system was fed with contained a lot of predominantly male-centered information. It didn't contain a lot of female recruitment data. So what was found out was that this AI system was turning down female applications, and it favored, that's a good example of bias, it favored male applicants. What happened was that the system was trained on 10 years of predominantly male hiring data. Of course, what happens is that when an AI system learns bias, it replicates that bias. That happened in 2018 in Amazon. Then also in America, a law enforcement AI system that was developed in 2016 was fed with a lot of black criminal data, colored criminal data, and as such, it was biased against people of color, and that directly influenced bail, sentencing, and parole decision against the affected demography. Then also in 2019, there was an healthcare algorithm bias, and that was also skewed against a particular demography, and it's of course affected healthcare decision that was given to that demography. So we can see that bias is not just something we talk about. Bias in AI is a very critical point that um, we need to take care of and we need to address. Now, moving ahead, data processing and AI compliance. Just we can't, of course, this session is too little for us to delve into the UK DPR, the EU AI Act, and some other the UK DPR, NDPR, EU GDPR, and some other data protection regulation. But then this data protection regulation, they've got foundations, they've got points that are similar across board, and that is what we'll discuss on this call. So all or major data protection regulations, they talk about lawful bias for processing. Now, for any data that we're getting to train our AI, there must be lawful basis for processing. You must have a lawful reason for collecting those data. And at this point, consent is very, very important. You must get the consent of the data owner for using their data for processing. And this becomes dicey because most organizations that have operated for a long time, they've got loads of data, customer data. Imagine a financial organization that has been running for 30, 40 years and are trying to develop an AI model. Of course, they've got loads of data that date back to decades. But then, for them to use this data for AI training, they must seek the consent of the data owners. It is criminal. It is criminal to use data for training where consent has not been sought. Also, in UK GDPR, there's Article 17. And Article 17 says, at any point in time, the data subject that has previously granted us that has previously granted us consent to use their data for training can request for deletion of their data. But this is now very dicey for AI system, because when they request, if they request for deletion of their data, yes, of course, we can delete their data in our databases, but this data is already in the training model. So what do we do? Do we now jettison? Do we now discard the whole? If one data subject tells, okay, I'm not, I don't want you to use my data for processing again, do we now jettison all the training that we have done and begin to now build a new model? This is one of the problems, because we can't retrain from scratch, and because it is costly and time consuming. Also, for data protection regulation, there is a requirement for data protection impact assessments. And what this does is that these are iris processing, including systematic profiling of categories of data. So the impact assessment is to see the impact of the data that we are using on individuals, on the society, and on nations. And for AI system data that we are using, we need to do continuous data protection impact assessment. Then also for data protection as well, of course, I know on this call there will be some data protection experts. There is a requirement for data minimization principle. So when you are collecting data and when you are using data to train AI system, there's a requirement that you collect only what is necessary. You must tell the owner of the data what you are going to use their data for, and you ensure that you collect only data that is necessary for what you are doing. You do not collect excess data that is not necessarily for your use case. Then also, that limitations for international transfers. So probably you want to use a Nigerian data to train data in South Africa, in Zimbabwe, in Ghana. But the last I checked for the NDPR, there are some jurisdiction-based constraints that some set of data that belongs to Nigerians must reside within the Nigerian environment. So again, there are some constraints on moving data for training across borders, across jurisdiction. So these are things we must consider when we are training data. Also, data subjects, that is the owner of the data, they have the right to tell you how you can use their data and what you can use their data from. Some data subjects can tell you that this data that I'm giving you for processing, I don't want you to use this for automated processing. And of course, if you get data you can use for automated processing, of course, it is useless in artificial intelligence, language model training. So these are the considerations when it comes to data protection and for AI compliance. Lawful bias for processing, you must get data, you must have a lawful basis for getting data. There's a right to erasure that the data subject owns. There is data protection impact assessments must be conducted. There are also international data transfer constraints. There's the data minimization principle, and there is also automated decision-making constraints for AI data. Okay, so Wale, at this point, do we go on the break or do we continue?
I think we can do 5 minutes break and come back 17:50. So 5 minutes, we will get back.
Okay, that's fine. Thank you.
So if you didn't join the first session, you can check what I pasted in the chat. That's the link for you to see the first lecture one, where Toluwani laid the foundation of what we are trying to wrap up today. And This also will be shared by latest by tomorrow, because we have another session for our chartered professional later today. So I should be able to complete that by tomorrow evening, latest maybe, because sometimes I don't know, YouTube sometimes just continue to roll and I can't upload. So I should get this up on Tuesday, oh sorry, on Monday latest, and then I will put a post up so that in case you missed out on it. We'll spend 4 minutes. So in 4 minutes, we'll spend 1 minute now. In 4 minutes, we'll get back.
So this was forward 13.
Okay, Toluwani, I think we can get started once you are ready.
Okay, please confirm you can hear me. Hello, Wally, please confirm you can hear me.
Yes, I can hear you.
Okay, that's fine. Thank you very much. Yeah, so welcome back, everybody. We're now on the home stretch. Yeah, so we're looking at the fifth point of discussion, that is secure AI development and deployment. Of course, for organizations that have software development functions, we have secure software development and deployment processes and procedures, but then there's a need to now incorporate AI development into our SDLC, secure development lifecycle. And we're going to look at 4 key things. Security by design. Of course, most organizations that have got security, software development function, they've got security by design. But the new things we now need to add is model hardening, API endpoint security. Most organizations that have got APIs in their software development processes, they've got that, but we now need to make this specific for AI system, and also production monitoring for AI systems. Now, security by design for AI systems. First, we need to start from the requirements gathering phase. We need to ensure that our threat modeling caters for AI threats. There are some threat modeling that are specific to traditional software development processes that does not cater for AI threat modeling. But for AI systems, we need to ensure that our threat modeling caters for AI threats. Also, as always, as we do previously, we need to ensure that there are security requirements, data classification, because AI, the bedrock of AI is data. And also, as part of our requirements, we need to conduct privacy impact assessments, because the data we are using for training might have some privacy constraints that need to be catered for. Also, at the design stage, we need to ensure that we conduct secure architecture modeling, access controls. Who and what need access, and what is the level of access? AI systems are quite ubiquitous and verbose, and as such, we have different systems coming to play. We have different technologies coming to play, a lot of service accounts, a lot of user accounts. Now, for AI system, we need to ensure that the access control that is designed into the system is in line with our secure architecture design. Also, there needs to be a lot of encryption. We have data that we're using for training, and this data have some privacy constraints. And as such, encryption also is a cardinal requirement for privacy. So we need to ensure that we have adequate encryption strategy, and in places where we need to isolate models, where models do not need to interact, where some set of data do not need to interact with other set of models. I'll give an example. So in practice, some organizations that embed AI into their ultimate service offerings, you find some customers that say, oh, we don't want our data to be used for training. We don't want our data to interact with other customer data. We want you to isolate our data. We want you to segment our data. So when we are designing this system, we must cater for data isolation. Then also, we need to have secure coding practices. We need to conduct a lot of scanning, model validation. Model validation is to ensure that the model is doing exactly what we have set it up to do. Then also there needs to be a lot of adversarial testing. And in subsequent slide, we'll have conversations, we'll see what adversarial testing is. Then of course, testing. For organizations that have got software development practices and processes, pen test is not a new thing. But our pen test should now consider AI specific vulnerabilities and threats. Also, robustness stress testing. In the last session we had last week, we discussed about robustness. And what is robustness? Robustness is the ability of an AI to be able to operate in unfamiliar situations or in situations where it is stressed. So, for example, if an AI system detects that somebody is trying to toy or somebody is trying to alter his data, how does the AI system react? Does it totally shut down? Does it totally shut down, or is it able to operate despite all the constraints around it? Robustness testing. And the fact about robustness testing is that if someone is trying to toy with our AI system, or if our AI system detects that there is malicious input, how does the AI system react to this? Also, fairness testing to see if our data is representative, to ensure that our data is not only looking at a part of the society or a part of the sample space and not considering other facets. Then also red team exercises, deployment. How and where are we deploying our AI systems? The AI gateways that we're using, how secure are they? Are we implementing rate limiting? And rate limiting basically is to ensure that a service gets an amount of system time. This is basically to reduce DDoS, that is denial of service attacks, to ensure that somebody cannot overwhelm our AI system and cause loss of availability. Because again, for security, we're looking at confidentiality, integrity, availability, and privacy of the systems. Those are the things that security under AI is concerned with. Availability is key. Of course, if you have an AI system, imagine you've developed something like a ChatGPT or a Claude or a Gemini, and for some reasons, some malicious users are able to overwhelm your system and they bring it down. Other users are not able to access your system. Of course, that will reduce trust in the system. So we need to look at things like throttling, rate limiting. Also, very important, input validation. We've discussed earlier that what goes into the AI system determines the output of the AI system. So you really want to validate your input. You really want to validate the input, because it is possible for malicious users to craft malicious input to make the system behave in a way that is not being designed. So you want to put constraint for input validation. And input validation is, I can give a simple example. So for example, if you are filling in a form online, you see that some forms, if on a field, if you need to put dates, you can see that the system is already set. The column for the part for days, they've already put the days. The days cannot be more than 31 because you can't have 32 days in any month in the Gregorian calendar. Then for the months, they've even given the list of the months, January to December. There's nothing more than that. Then for the years, there are some restriction because there is no natural person that is alive now that can be born in 1880. So we need to put some validation constraint to ensure that the data that is imputed into the AI system is congruent with what we expect. Then also operations. So at the point after we design, after we develop, after we've test, after we deploy, this AI system, where it gives business value is when it goes into operation. Imagine that ChatGPT has developed and they've done everything, and the tool remains in development. it doesn't come into operations. Then the business is not making money. It doesn't provide significant value for the business. So the operations is where the business gets significant value. And in the operations, we need to ensure that there's continuous monitoring. There's drift detection. Drift detection is when your AI model is not able to give real life output, when the data you have is not representative of the current challenges. Also, incident response. If something goes wrong, how does your AI system detect this and how is it handled? Then model retraining controls. You need to continue training your models for it to be effective and for it to meet real world challenges. Now, so requirements, we've discussed about the requirements, we discussed about the design. So for the requirements, there must be documented and approved requirements. There must be data quality requirements. What is the quality of the data you need? What is the fairness criteria to reduce bias? Also, explainability requirements. So for AI, it is expected that organizations that develop AI systems must be able to explain how AI comes into conclusion or how it develops output. So, for example, if we're developing an HR system that is being driven by AI, and somebody is being denied, how can we explain how the AI system came into conclusion that this person should not be employed? If we have a credit system that is driven by AI and someone is denied credit, can we explain how the AI came into conclusion that this person should not be granted this credit? Acceptable error limit, adversarial robustness threshold. Sorry, we discussed about that. Then design, model isolation, training pipeline security, data flow classification. Then testing, adversarial robustness testing. So again, for testing, we must have capability to train our AI data with adversarial data to ensure that our AI system can recognize wrong data and how it addresses that. Then also, we've discussed about deployment and operations. Yeah. So adversarial training is to train models on adversarial examples. So it's just basically what adversarial training is, just to show the AI that this is an example of wrong and unacceptable data, and this is how you treat this data. So it is training models on adversarial examples to improve robustness against crafted inputs. Then input validation, we've discussed about that. Provide guardrails for the kind of inputs that we're expecting so that someone does not maliciously craft adversarial input into the system to overwhelm the system or to ensure that or to make the system bring output different from what we expect. So, for example, for input validation, we've discussed that to ensure that we provide guardrails and the data the system is able to accept data in the way we want it to come in. Then output filtering. This is very important because for output filtering, there are some attacks that can be crafted to make the AI system divulge information about how it is set up or about the models. So again, we need to ensure that we put constraints on how, or guardrails on how the model generates output. And that is to guard against information leakage, to ensure content generation, and to ensure that the content that it generates is what we have expected it to do. Then, of course, encryption is ubiquitous around AI system, just like we have around traditional software development system. Encryption at rest, encryption in transit, and encryption during processing. For those of us that are used to software development control, software development security, we are aware of the OWASP top 10. for software development. But OAPs again have done a very good job in developing top 10 for large language model application. And it looked at some of the things that we are used to in the traditional software development controls, OAPs top 10. Prompt injection. Now we need to ensure that we set up the systems that detect when somebody is trying to put some prompts or some input that we override system instruction. Also, we've discussed about insecure output handling is to ensure that the output that we get from AI system is what we have designed it. The AI system does not generate output that negates privacy, output that surreptitiously diverges information about the AI training data or how the AI model is set up. Then training data poisoning. So for data poisoning is an attack that is specific to training data. And what data poisoning does is to create bias or um, to create vulnerabilities in training data, because we've discussed what goes into the training data comes out in the output. So we need to ensure that we vet our training data properly to ensure that poisoning doesn't occur. Then model denial of service, that is loss of availability. If you have if you have a large language model that you have put into production, if there's a denial of service and it's unavailable, you are not making money, and that does not help you to achieve your strategic objectives. So we need to ensure that we put in availability constraint, load balancing, business continuity, incident response, and all other control, and also to ensure that attackers are not able to degrade performance. Things like throttling will help to ensure that one person cannot take over the system and ensure that there's a denial of service. Also, supply chain vulnerabilities. Most of the data we get, for training data does not belong to the organization, they buy data. And if those data are corrupted, if there are bias in those data, it goes into our output. Then again, for supply chain vulnerabilities, some of the AI systems we have in practice, so for most organizations that use AI, they are not the developers of the AI. So most organizations embed AI products into their service offering. So if there's bias, if there are threats, if there are vulnerability in those models, it ultimately affects the output of the output our customers get. So we need to ensure that third-party security is conducted. Third-party security is very important in AI systems. Then sensitive information disclosure. Again, that ties to insecure output handling. We need to ensure that our data does not surreptitiously give out output that contains sensitive information, especially from the training data. Then insecure plugin design. Of course, AI system is a combination of different systems talking to each other in practice. Now, most of these systems communicate either through plugin or through AI. We need to ensure that our AIs and our plugins, they get the correct level of access or permissions that they need. I'll give you an example that happened in practice. So I worked with someone who was trying to who was building a website with AI. And we did some scanning and the AI gave an output. The output was wrong, and we questioned the AI that this output, this vulnerability is wrong. Why did you give this output? But because the AI had excess access into the source code repository, the AI began to rewrite the whole source code to justify the error it made. So we need to ensure that we don't have insecure plugin design, and also there's no excessive agency. Excessive agency works in a lot of organizations because the AI system is granted too much permissions. We need to ensure that the LLM is giving the exact permission it needs. The example I just gave now, because the AI system had excessive agency, it began to rewrite the source code to justify the error it has made. Then over reliance, this happens everywhere. Some people or most people, AI is the gospel truth. Whatever AI churns out is taken as the fact. So we need to develop a systems where we need to verify, because even as much as AI has developed, I can categorically say without any shadow of contradiction that AI is still in a lot of developmental stage. At this point, we can't absolutely rely on the output of AI. So this is the place again where we are reiterating human in the loop, or ETL, that we do not need to over rely on AI output. We need to verify the output. Then model theft. This goes without saying. Most organizations are training AI models. Some people are how to steal the models. And when they steal these models, they use it for, most AI models are proprietary, but there are people looking out to steal this model and use it for their own private gain. So we need to provide a lot of controls, such as either patenting our AI models, or the legal controls we can put around our AI models to ensure that there is no model theft. Then, of course, for AI security and monitoring, securing AI apps, we need to have strong authentication. We've discussed about rate limiting, input sanitization, response filtering. We've discussed about it. Then TLS encryption. We need to ensure that for all in transit, in transit, and at rest, we encrypt our communication pathways. TLS 1.2 and 1.3 are what is secure currently. Then also there should be audit logging. All the decisions that are made by our AI system should be logged, so that if we need to conduct a postmortem review, we have enough data, we have enough logs to conduct this review on. And also for production monitoring, we need to look at production model performance. We discussed about model drift, data distribution and shift monitoring, anomalies query pattern detection, also adversarial input detection. We should be able to know when someone is trying to toy with our system. Then bias metric tracking over time, we've discussed about this, and also automated alerting and escalation. For model drift, it is divided into two majorly. There is data drift, and this data drift is based off the data that we are feeding into the AI system. So data drift occurs because there's a drift in the data. For example, an e-commerce system that is being fed with summertime shopping. For summer, there are some goods that customer would order because of the weather. And if we use this data to make predictions for winter sales, definitely there will be a drift in this, because the kind of purchase that is made in winter is different from what is made in summer. Also, there is what we call concept drift. Concept drift is because the processing reality has changed. And a good example is if we train a system for, let's use fraud detection. For example, we train a system for fraud detection, and for the time we've trained it, the country was using Mark Stripe. Then the country moves to chip and pin. If we're using data from Mark Stripe, it will not be representative of the chip and pin, because the concept of the business or the concept of the processing reality has changed over time. Now, going to the final section we have today is now tying everything we've discussed from last week and also for the past 1 hour together on how to build an AI security strategy. The first thing is governance and ownership. Management, the board, or whoever it is that is the ultimate decision-making arm of the organization should own AI governance. And this dovetails into policy framework, incident response, responsible AI, and also we'll look at a group exercise, or we can take it home and if you like, we can use it. That will help in reinforcing what we've discussed so far. Now, AI security policy framework. The AI security policy should be approved by the highest approval authority within the organization because it sets the tone and it sets the scope for AI activities, AI security activities within the organization. Also, there should be an AI risk management standard which should help with AI risk identification, assessment, and treatment. And of course, we've had conversations around AI development and development guidelines and also operationalization of AI systems within the organization. So for the policy, what do we include? There must be a scope. What do we need AI for in the system? What is AI helping with the system? What part of the organization is AI going to operate? What language, what machine learning models are we using? What LLM integrations are we using? Are we developing AI systems within the organization, or are we using third-party AI systems or API? Are we using AIs for automated decision making? Then also we need to have an acceptable use policy for AI. And this discuss about the permitted and prohibited use of AI within the organization, because this is very critical because most organizations are behaving like an ostrich that is burying his head in the sand. Uh, we're not recognizing we're not recognizing the use of AI, but a lot of staff are using AI in their business output, either ChatGPT, Copilot, or Claude. And inadvertently, they are ferrying company confidential data or private data into the system. So there should be an acceptable AI use policy. Then also there should be data governance. There should be requirement for training data quality. There should be requirement for bias assessment, provenance, privacy, retention, and data disposal. And this AI should be part of our data governance policy. Then also our risk management process. AI should be embedded into it depending on business realities, regulatory or industry requirements. Some countries have specific AI requirements. If you're in the EU, there's a EU AI Act. So if you are in your risk management process, EU AI Act, if you are operating in the EU, should be a consideration. Then also, very importantly, for the AI policy, there should be roles and responsibility. Somebody should own the risk, things like AI risk of somebody should own the risk. Somebody should own the risk. Somebody should be accountable for the risk. Somebody should be responsible for the risk. Somebody should be, I said accountable. Somebody should be consulted and people can be informed. Then also due diligence for third-party AI system. A lot of organizations who don't even embed AI into their final service offering, they use Copilot, they use ChatGPT, they use Claude and other AI systems. Definitely, there should be due diligence. There should be supplier security assessment, contractual requirement, and SLA monitoring. And also, especially for organizations that are embedding AI systems into their service offering, there should be right to audit clauses. Now, AI has made incident response move from what we know incident response to be traditionally. Now, incident response within every organization that uses AI should cater for AI incidents. And of course, this is a model for AI incident response: detect, assess, contain, remediate, and recover. So detect, we must be able to build our system to detect AI specific risks such as anomalous model behavior. We must be able to train our systems to detect bias alert, adversarial input patterns, data drift signals. Also, we must be able to assess. So when our system detects AI specific risk, we must be able to assess to determine the scope and the impact of the incident. Is the model compromised? Is our data compromised? Is training data affected? As is our output reliable based on what we've detected? Also, after the assessment, the next important thing is to contain, to ensure that this incident does not spiral out of where it has affected. So for this, do we disable our models? Do we disable AI APIs? Do we switch to fallback systems? And how do we preserve evidence for investigation? Then, of course, we move over to remediate. That is now looking at the root cause analysis. How did this happen? We've seen how this happened now. Based on what has happened, do we need to retrain our model with clean data? Do we need to patch vulnerability? Do we need to update controls? Then also, of course, recover. Recover is to ensure that we now go back to the state we were before the incident occurred. Yeah. So these are just some AI incidents that have occurred. What we'll do after this call, we'll share these slides with everybody that's present on this call so that we can read. This is just for knowledge purposes. Look at AI incidents that has happened previously, poison model on organ phase, prompt injection by customer call, then bias detection in credit scoring. Then, very importantly in AI is response. So as part of the governance of AI, we need to have responsible AI and ethics. And that has 4 cardinal points. That is transparency, accountability, fairness, and privacy. For transparency, we must be able to explain AI decision with clear documentation and stakeholder capabilities about AI, stakeholder communication about AI capabilities and limitation. So explainable, we've already discussed about it. If an AI system comes to conclusion, we must be able to explain how the AI system came to that conclusion. Also for AI systems, especially for organizations that are developing AI systems, organizations that are embedding AI into their service offering, there must be clear documentation of the AI process. And also in this documentation, we must also put AI capabilities and limitation. What is this AI system set up to do? And what are the limitations of this AI system? So that the user at the first glance is able to understand the capabilities of the AI and what the AI system cannot do. And that helps in making decision on how to use the AI, transparency. Then also accountability. There must be clear ownership of AI systems with defined roles and responsibilities. So who is accountable? Somebody or a group of persons within an organization must be accountable for the final outcome of AI systems. Decision has to be made. Is it the board? Is it management? Is it the AI developers? Who is accountable for the final outcome of AI system? That is adequate governance, because AI system must have adequate governance and oversight functions. Then also fairness. We've discussed a lot about bias prevention, equitable treatment across demographics, especially consideration and inclusive design principles. So the AI system must be, the output of the AI system must be adjudged to be fair as possible. Then also privacy. We are getting data to train our AI models and there are privacy constraints. So privacy is part of privacy, fairness, accountability, and transparency are part of responsible AI and ethics. Okay, so we have just a group exercise, but time will fail us to go into this. We can, if we choose to, we can use this as for learning purposes. So a mid-sized financial organization is deploying AI-powered credit scoring system and customer-facing chatbot. They currently have ISO 27001. So that means the organization has considerable cyber security controls, but there's no specific AI security control. So build a 12-month AI security roadmap. Now, finally, what are this program takeaway? Number one, data is the foundation of AI systems. So securing data integrity, provenance, and privacy is essential for trustworthy AI. Security by design must be embedded across the AI development lifecycle. So security by design, the best way I like to explain security by design is like we're building a house. So if you look at anybody who's building a house, any architect or any developer that knows his onions will have a plan. You know where the doors are, you know where the windows are, you know where the rooms are, you know where the kitchen is, or whatever you want to put into your building. Security by design is that you have already designed security controls to be built into the process. So imagine you've built a house and you built it all walls, no doors, no windows. Then after you've built it, you've roofed it, everything is fine. Then you now decide, okay, there's a door is supposed to be here. A window is supposed to be here. This is supposed to be an arc. Then you now start breaking down the walls. Of course, you can do that. That's fine. But doing that affect the integrity of the system. It would have been better if you have made considerations for doors and for windows. That will make your building more tidy. So the same thing into security by design. We need to build security in, make controls for security, ensure that security is not reactive. We do proactive security into AI system design. And also model hardening, things like adversarial training, train our data on adversarial data, train our models on adversarial data to ensure that they are aware of what adversarial data looks like and they can react to that. Also implement input validation and output filtering to protect against AI-specific attacks. Also, we need to ensure that there's an AI security strategy with clear. In fact, this is the first thing. This is the most important thing. AI security is top down. It starts from the top. Management must own AI outcomes. There must be adequate governance, and there must be responsible AI adoption within organization. So here is a list of resources that was used in developing this slide. That's the ISO for 2001, the 2023 version, the Artificial Intelligence Management System, the NIST AI Risk Management Framework, the OAPS Top 10 for Large Language Models, the EU AI Act, the EU AI Regulation White Paper, as well as the MITRE Atlas documentation for adversarial threat landscape for AI system. Yeah, here is where we draw the curtain for this two-part session on foundations of AI security. Thank you for joining, and I hope we've learned a thing or two. And this is the point where we now welcome questions, observations, and contributions into what we discussed either last week or this week. Thank you very much.
Thanks a lot, Toluwani. We'll just, okay. Questions, do you want to type or can I give you the mic? Which do you prefer? Okay, you can unmute if you want to ask on the mic, or you can put the question in the chat. Anyone, whichever you are comfortable with. If you want to ask question, just put up your hands and I will unmute you.
Yeah, thank you, Wally. Thank you, the moderator and the speaker. So when you were talking, you mentioned something about forensic something. I couldn't write it down because I was on transit. So I was wondering that I think that has to do only with forensic study. When you're doing chain of custody and all that, maybe it was chain of custody. Yes, it was chain of custody you mentioned. So I was wondering how forensic issue came into the foundation of AI and AI governance. Also, okay, I will send the other one. So I will send the other one by text. Thank you.
Okay. Adenuga, thank you very much for your question. So the chain of custody we're talking about, if I remember, was about data provenance. So AI systems are developed basically on training data. You get data and you're training that. So for this use case, chain of custody ties to data provenance. You must be able to account for the life cycle of your data. Where's your data coming from? Where did you get that data from? What transformation have you done on those data? What output are you expecting? And how are you expected to sunset that data at the end of its life cycle? So that is what we mean in chain of custody as regards for the purpose of this conversation.
All right, thank you. I hope that helps. There's a question in the chat. I'll just read it. These models, so hi Tolu, brilliant submissions. These models have external controls, management, and organizations only utilize them to enhance productivity. How do we establish if there are backdoors or vulnerabilities that we can't really identify from the front end?
Okay, thank you very much, Ugo, for this question. And this is an experience question, and this is a very practical question. So, in reality, for organizations that use things like Copilot, ChatGPT, um, of course, it's very difficult for the board or for management to say we're not using these tools again, and we use them for productivity. So, the best way is these organizations, they have security reports. There are SOC 2 reports, there are ISO 42001 reports, there's ISO 27001 reports. And for these reports, especially for things like SOC 2 reports, you are able to see the controls that are tested and the control variance in this report. So basically, even so, for example, if you are using Microsoft Azure, if there's a vulnerability, it's very difficult to use to say, oh, because there's vulnerability in Azure, you are moving your estate into AWS. It doesn't work like that. But the idea is that you are able to recognize that this is the shortcoming or the limitation, and where you can now develop compensating controls. You know, when we're having this conversation, we spoke about explainability and where the LLM developer should develop things like documentation that contains the use case and the limitations of the AI system. So if you go through as part of your third-party governance, if you go through this documentation and you are able to see that this is the use case and this is the limitation of this AI model, then you are able to act appropriately in-house to be able to say, okay, this AI system cannot go this far. Therefore, we will not extend our use case to this extent. So again, it's all about third-party governance. Know what your AI tools are capable of and their limitations, and that will help with the governance process. I hope that answers your question.
Thank you, Toluwani. There's a question, another question in the chat. In terms of AI incident response, how are we able to detect AI incidents?
Okay, so thank you very much for this question. So this is practical as well. So AI systems have got specific incidents or specific vulnerabilities and threats that are not applicable to traditional systems. For example, bias detection. Bias detection is an incident. Model drift is an incident. So we need to first to retweak our incidents governance process to ensure that we have processes to detect AI specific incidents. And we need to develop technical capability. So we need governance, We need process and we need technical capabilities to detect AI incidents. For example, for bias, there are some tools we can run through AI, Fairness 360, and some other tools that can help us. For model drift, we need to keep monitoring the output of our AI system. We need to, for example, the example I gave while we were in the course of the conversation was, for example, if we have an AI system that is helping us with fraud detection, and the training data we use is for magnetic stripe for swiping cards. Now, there is now a new business case that is chip and pin, where you can now use your card, you can you slot in your card and you put in some pin. If you don't train your data away from mag stripe and the system is beginning to use chip and pin, that means there's a drift. So first thing, governance, monitoring, technical controls, and also adequate monitoring to look at the business operational landscape of our AI system. What are the new threats that we have? And we also need to ensure that for the new business reality, the training data that we use caters for that. I hope that answers your question.
All right, thank you. I think we have, maybe this will probably be our last question, because I have another session in about 20 minutes time. So Adronka is asking, you talked about perturbation. Could you please speak more on how robustness is achieved? Does this solve adversarial attack? What are the KPI for this?
Okay. I don't get perturbations is just surreptitious change in training in data that is not that's not visible to the ordinary eye. So, for example, the example I gave, a self-driving car has been trained on road signs. Red is stop, green is go. Now somebody tweaks the training data, and in the full red, it just changed a pixel. When that single pixel is changed, the training data is not able, the AI system is not able to interpret that as what it was trained against. Robustness is to ensure that we set up our system in a way that, so example of robustness, if your AI system is beginning to get inputs different from what is expecting, what does it do? So let me give an example. For example, if you are filling a form online and in the number field, you are trying to put alphabet, how does the system trains that? You see that for some system, it just keeps telling you that only alphabet is expected in this field, or only numbers are expected in this field. So that's an example of robustness. To ensure that you don't overwhelm, you don't surreptitiously craft inputs that will overwhelm the system, or that will make the system behave in a way that's not designed to behave. Also, if the system is getting so many requests other than what it is built for, how does the system react? All this needs to be factored into building a robust AI system. Now, so could you please speak on how robustness is achieved? Does this solve adversarial attacks? Adversarial attacks is an ongoing process because adversaries don't stop. So what we can do is, for the information you have now about adversarial attack, you need to train your system to be able to deal with that. Of course, there'll be more in the future. This doesn't end. Then what are the KPIs for this? So specific KPI for this is that the KPIs, the best KPIs for AI system are business and operational. So if you have a fraud management system, what is the mean time to detect fraud vis-a-vis false positives. So KPIs are set based on the business requirement of the AI system. KPIs are set based on the KPIs of, based on the business requirement. Why was the AI system set up? What is it set to achieve? How does it achieve that? Barring adversarial attacks or other threats in its operating environment. I hope that answers your question.
All right. Thank you. I think we would like to stop there now. As I promised, we will get this up before Monday. I will try to get it out on Sunday. Hopefully YouTube doesn't misbehave. And in less than, I think, what time is it now? In less than 15, about 15 minutes, I will be joining another session. So we have to schedule this back to back in case you want to. So the next conversation is around the cybersecurity job market and the expectations of people. So we've invited someone to come speak about the noise around cybersecurity, the expectation people come to cybersecurity with, and sometimes some people are disappointed because they've been looking for that opportunity for a while and they can't see. So I've invited someone to come speak about demystifying that, and hopefully we will get clarity from that session. So thank you so much, Toluwani, for
yeah, sorry. I think Adoronke is saying she'll reach out. She's a trustworthy AI researcher. So Adoronke can reach out to me on LinkedIn and we can take the conversations further.
All right. Thank you. And yeah, I think it's a good it's a good time to end the session. Thanks, Toluwani, for your for volunteering to share with us and add more to the community. Thank you so much, and thanks everyone for joining us. I think we got good number of people that joined both the first and the second session. The first recording is online. You can pick it up on our YouTube channel, and this will also go live before Monday. And it's a good place to end it today. And if you are joining us for the next session, you can I've dropped the link in the chat if you didn't see it before now or you haven't registered, so register, and I'll see you again in a few minutes. Thanks and bye.